Video number 264, the double angle identity. Here we are, we have sine of 2a, so sine of twice as much as a, which is why we have it's called the double angle identity. This one's easy. Sine double a equals 2 sine a cosine a. Alright, that one's pretty straightforward. And now cosine of the cosine double angle, it's not more difficult, it's just you have three choices. And the reason there are three choices is because you could always make a substitution in for cosine squared. So cosine double angle, cosine 2a, will equal cosine squared of a minus sine squared of a. And of course, because cosine squared could be written as what? 1 minus sine squared, you'll end up with a 1 minus another one of those, which is why it's 2 sine a sine squared a. Okay? Then for cosine double a, you can also rewrite sine squared as, that would end up being 1 minus cosine squared. So therefore, after distributing that minus sign into 1 minus cosine, you'll end up with an extra cosine. So therefore, you end up with 2 cosine squared a's and then minus 1. Now, we're not going to go through the proof, but you can easily see, if you start writing this down and go through the, if you just rewrite sine double angle at sine 2a as sine of a plus a, then you can use what? The addition identity, sine of the angle addition. So, in the previous videos, we had sine a plus b. You can then change that around and you'll eventually get this one here. If you do cosine double angle, cosine a plus a, and you expand this out by using the cosine addition identity, then you can definitely get to that one right there. Okay? So in the rest of this video here, let's go through and try a few sample problems. Here is the first one. Find the values of sine x and cosine x given that cosine double angle equals 2/3 and cosine double theta. All right. And theta is between 90 and 180, which means theta is in quadrant 2. Okay, so you're in quadrant 2. So here we are. Cosine 2 theta equals 2/3 does not mean theta equals 1/3. No. Okay? What it does mean, though, is that you can say 2/3 equals one of those. One of these three. So you got 2/3 equals 1 minus sine squared theta. And then, of course, all you have to do now is solve for theta. So multiply everything by 3. There you are. Subtract this 3, okay, to get this. Divide by negative 1/6 to get positive 1/6. Square root on both sides gives us root 6 over 6. And that will be sine theta. Okay, now they don't ask us to find theta, but they just want us to find the sine and cosine of the single angle, sine of x, cosine x. So that's something we've already done. We've got the sine of theta. Now we're going to go back and find cosine theta. So let me go back to just a standard, regular, basically the first trig identity that we used, which was just simply the Pythagorean Theorem. And even at the time that we used this trig identity, we really didn't even think about it as an identity. We were just talking about circles and the relationship to a right triangle. So you just plug it into sine squared, cosine squared. Of course, plug it in this one now. So you don't even use the 2/3. You use the root 6 over 6. Next one, we're going to rewrite cosine triple x in terms of cosine single x. All right. So we're going to basically use cosine triple angle, so cosine 3x. And the trick on that is this. Rewrite your 3x's as 2x plus x. Then what? Use the cosine addition identity. And then we use cosine first angle, cosine second angle, minus, remember cosine's backwards, minus sine first angle, sine second angle. Then we rewrite the cosine double angle as one of these three. Oh, where are we? one of these three here, one of these three substitutions. Just pick one, see what happens. Now, we wanted it in terms of cosines. That's why I probably picked the cosine one. I picked the one that doesn't have sine in it at all, so I didn't use the first two. I used the last one. So there it is. Distributive property. And you're in good shape. So you just work with that over here. You end up with cosine cubed x. Over here, this is 2 sine x. This is supposed to be cosine x. There we go. Oh, one more there. Okay. And we're in good shape, so you go ahead and multiply this sine x in here, so you end up with 2 sine squared x. Then, of course, sine squared can be replaced with 1 minus cosine. Why would I do that? Because they want us to write this in terms of cosine, so I take my sines and replace them with cosines. And it's just a matter of distributing here, amplifying everything by 2. So basically distribute both the 2 and the cosine x to get this. And then now you end up with 2 of those, 2 more of them, so you end up with 4. You got a minus 1 cosine x, minus 2 cosine x. That's a total of minus 3 cosines. So there you have it. The double angle identity for sine and cosine.